Okay, this is a Project Euler exercise. This is question 4 from the Project Euler programming exercise series, which is for people who are new to computing to test out their skills and develop their skills in computing and numerical programming. I'm using Jupyter notebooks and I am using Julia version 1.6.1. This series is meant for students of mathematics, engineering, science students in universities who are doing coding and computer science too, but it's welcome. Oh, it's open to everybody. Now, this is an interesting one. Project Euler question 4. A palindromic number reads the same both ways. So if you're reading it, the digits out forwards, you should get the same backwards. For example, 121, 121, that reads forwards and backwards. The largest palindromic number made from the product of two two-digit numbers is 9009. That is the product of 91 and 99. Okay, so the question here is find the product of the largest palindrome made from the product of two three-digit numbers. Okay, so something that helps us here, or two commands that will help us, is string and reverse. String converts a number to a string, and reverse, amongst other things, will reverse the order of the elements of a string. Okay, so let's start off here. I've got a number here, 1, 2, 3, 4, 5. Let's turn that into a string. There we go. Let's just check the type there. Not that it's necessary, but it's just always a good idea to keep an eye on types on an ongoing basis. So it's a string. Now let's reverse the string. Let's reverse the string that it created from 1, 2, 3, 4, 5. There we have it there. 5, 4, 3, 2, 1. Okay, so what we're going to do here is create a function to check if a number is a palindrome. Palindrome even. So function. So just create a function here, declare a function, and we're going to name the function palindrome, is palindrome. The argument is simply an integer n. And what this function does is it returns a true or false depending on whether or not the reverse of a string is equal to the string. Okay, that's all it does. Okay, so if a number reads the same back and forth, that will return true. So let's just try it out in some examples here. Better declare that or run that first. So let's try it out in some examples there. 55, yes, that is a palindrome. 5105, no. And we know 909 to be a palindrome. So true, false, true. Okay. Now, what I got to do is create the product of every single three-digit number multiplied by the product of every other three-digit number. Or, sorry, multiplied by every other three-digit number. Okay? So let's see how this will work. Now, this is not going to work, this approach here. But let's just create a vector times a vector, element-wise calculation. Does this work? Will this approach work? No. We're only getting the squares. So the first element of 1 multiplied by the first element of the second element times the second element, and the third element times the third element. That's not what we want. We want 9 values altogether, and some of them will be replicated. But yeah, so that's not what we want. So what we're going to do here is use a comprehension. Okay. So what we're going to do here is just multiply out. We have the range of numbers, the range of possible three-digit numbers, 100 to 999. There's about 900 of them there. And likewise, y in 100 to 999. Okay, so essentially what we're going to do there is products. Okay, so that creates a 900 times 900 matrix. And you can tell we got duplicates there. That doesn't really matter. Okay, just as a quick remark though, we can spot that we have a palindrome very early there. Okay, not that that's particularly important right now, but there's one that's one we're looking for straight away. So what we need to do is flatten that into a vector. Okay, so that's interesting, but this matrix here. But what we can do is just flatten that into a vector because it'll make it easier to work with. Simply, all we have to do there is type in vec. Okay. Now, it's not sorted or anything like that, and it's probably loads of duplicates in it, but that is not really important right now. Okay. So, yeah, we have 810,000 items, elements in this vector. Okay. So what we can do there is determine which ones are palindromes using is palindrome. Okay. Dot products. Okay. So not a lot to begin with. That's not a problem. But what we can do is use that command to subset products, all of the products, just to contain the ones that are palindromes. Remember, this will essentially return true or false. Okay. So let's run that. Now, there we go. So it turns out we have 2,470 three-digit, palindromes made from multiples of three-digit numbers. The products of two three-digit numbers. Okay. The largest of which is, well, I don't know what the largest one is, but just to run it anyway. Oh yeah, just actually as a remark, they're not in order here. Just be careful about that. So what we can do there is just check what the extrema is. Okay. The extrema is the minimum and the maximum. So we've seen that the minimum there was, we saw it earlier on, it's 10,201. The maximum is 906,609. Okay.